Just
Now
notify
it
me.
has started.
Hmm.
So, hi everyone. Well, for those who will be watching this at our Друзі Kunsht community website, hi, it's me, Oksana Brushnivska, and this is Kunsht Camera, our type of interview that we do together with you people while asking our guests and asking our community members to join and to discuss some interesting topic that we're all has some questions about. And today we have a very special and dearest guest who we were all really waiting for. This is Richard A. Muller, American physicist and a science writer who's an author of great popular science books, one of which I'm having translated here in Ukraine. It is called Now the Physics of Time. And Professor Muller, as I already said, thank you very much for coming. And thank you very much for your support and for everything you have already said. And let me start asking you now about things we're all really interested in and want to talk about a lot. Of course, we have some limited time and we will talk about time here. And let me start with actually using one of your techniques, probably, that I saw here while I was reading your text, but probably in a slightly different way. Well, since you greeted me and I greeted you, and since we had this little introduction in the beginning of our conversation, you said a few words, I said a few words, Alessa said a few words about you, about us. And since it all started, some of the time has already passed, and a piece of our conversation is already behind in the past, and some other piece is still to come, I hope, in the future. So this conversation is not something really, really long, but it still already has its past and its future. And me stating this obvious fact is something that is happening right now. So my question is, what is this moment for you? And what does now mean to Richard Muller, who's wrote this amazing book about time, including the concept of now? So what does now mean to you?
Oh, I take a book to explain it because it is, for one thing, there are so many what I consider misexplanations. There's even a whole group of physicists who are saying now is an illusion. Time doesn't move. And when I look at what they do, I have this advantageous position that I understand their physics. I understand their theories, and I can look at it and say, that's all, let me use a kind word, baloney. What they're saying is that their theory doesn't explain the movement of time. And therefore, they arrogantly conclude, so the movement of time doesn't exist. The movement of time has really bothered Einstein. He couldn't get it into his theory of relativity as much as he tried. He was the master of time. I say Einstein gave us the gift of time because prior to Einstein, time was that's the background. It's like time and space were where physics occurred inside this realm. It was the stage in which the play took place. But when Einstein came, he said, let's examine the stage. And he came up with amazing things that were quickly verified experimentally about time, the time experienced by two different objects going along different paths was different. What? I mean, that is so out of the box that it made him into, ironically, he was the man of the year for a magazine in the US called Time magazine. He gave us time, and time as a subject of study. And in all the studies of time, and there are a lot of them, and I'm familiar with them, and there's been really not a whole lot of progress since Einstein. The one thing that Einstein despaired of was this movement of time. Why? He unified time and space, but we're all kind of sitting still. Yeah, you could say the Earth is going around the sun, but in its general relativity, you could easily put the Earth at the center of the universe, and then we're not moving. But you can't do that with time. Time keeps on progressing. So the question I was wrestling with is, what is the meaning of the progression of time? Eddington came up with a theory that's related to entropy. And all sorts of great physicists have just jumped on board and said that. Hawking said, yeah, it's obviously entropy. I don't want to get into entropy because my conclusion is it's obviously not entropy. All these great physicists from Hawking to Eddington, excuse me, uh, are wrong. And I could discuss that at great length, but I discuss it in my book. I'm hoping that my book will provide the death of the entropy theory by all the examples I give of why it's not true. So that doesn't answer the question. Why isn't it? What is it if it's not entropy? And this gets me into one of my favorite topics, which I didn't expect to when I got into that book. It's interesting when you write a book. I thought, everybody's understanding of time is so messed up. Let me just put down all of the mistakes they make to clear the water so we can think clearly. I didn't expect when I was writing this book to actually come up with a possible answer. I call it a possible answer because nothing is true in physics until you verify it experimentally. So I had to come up with a way to verifying it experimentally. Made a proposal there, and the experiments are being done, and we will see. So I hope we will verify this. But it wound up getting tied into another one of my favorite topics, which is freedom of will. Now, in the 1800s, there are all sorts of papers written at a time when physics was advancing so rapidly, it looked like physics could explain everything. And so many of the great philosophers of the 1800s said, free will is an illusion. You can get a robot. You can now these days you might have an AI robot who says, yes, I have free will. And you know he doesn't, or does he? It's an interesting issue. Back in the 1800s, it looked like physics could explain everything. But we learned in the early 1900s that it cannot. At least the current state of physics is that there is an uncertainty in physics, and it is incapable of predicting the future, even if you knew the time and position and of all the molecules in the whole world. You still can't predict the future. You can have two identical atoms of radioactive carbon, uranium, and one will explode and the other will explode later, but they're identical. What do you mean identical? Well, in physics, we have a way of proving they're identical by interfering them. And so there's no physical difference between the two, nothing that physics can detect, and yet they explode at different times. Is that free will? No, I don't call that free will. But what it does show is that the arguments of the 1800s was wrong. That the idea that physics can, if identical things behave differently, then the concept that physics can explain everything is simply wrong. Okay, we can still explain on average uranium takes so many years before it explodes. But that's like me predicting that I will probably not live more than 120 years. So what surprised me was when I had a concept of time, to understand it, I had to bring in something from outside of physics, which was my free will. And let me just jump to the end. I spend a whole book building up to this point. And so, what did they say? Well, a viewer warning that we giving away the climax of the movie. We're telling you who done it. The bottom line is that, of course, time exists all the way into the infinite past and the infinite future. Well, actually, my theory is it doesn't. My theory is that new time is always being created. The past exists in some sense. We know of it. We can describe it. Some of us remember things of our own lives. You remember things of your own lives. So in that sense, the past is there. Um, some people think you can go back to the past and change it, and there's lots of science fiction on this. According to my theory, no, sorry, science fiction fans, you can't go back in time and change things. If you could, it would deny free will. Now, free will is not a solid result. It may be an illusion, but you can't rule it out based on the ability of physics to predict the future based on physical things alone. The decay of atoms shows that physics can't predict everything. That allows free will to exist. So I think free will does exist, and it doesn't mean that I'm not influenced by my parents and my friends, but wrestling with this concept of free will is something I try to do in that book. Uh, so my concept is when the universe is expanding, the standard physics theory created by Einstein, published in 1916, over 100 years ago, many people misunderstand that. They think the universe is expanding into other empty space. And that is not the theory of Einstein. Maybe it's your theory, and maybe you're right. But it's not Einstein's theory. It's not the theory of general relativity. The theory of general relativity is far more out of the box than that. What he said is everything is fixed in the universe, but space is expanding. And when he does that, he's led to a whole host of predictions that turned out to be true. Eddington, who mistakenly thought entropy drove time, was one of the first people to ever verify that Einstein's predictions were true by during an eclipse of the sun. He looked at the deflection of starlight, a prediction that Einstein made that nobody had ever made. Nobody had ever done the test. It can only be done during an eclipse of the sun when you can see a star that's close to the rim of the sun. And the fact that its position seems to shift when it's close to the sun, that's an indication that light does bend, which was a prediction of his general relativity theory. So that was just the first of a series. We don't want to go into general relativity, but his theory for the universe is that, in some sense, galaxies are not moving away from each other. More space is being created in between them. That may sound absurd, but that's the theory that's over 100 years old and has been verified with many predictions that have come out to be true. So let's start by assuming that's true. Now, if space is created, wait, I thought general relativity unified space and time. Space is being created. What about time? Well, it's not in general relativity that time is being created. And why is that? Let's just say it was Einstein's greatest oversight. That yes, space and time are unified. Space is being created all the time. Not all the time. I have to watch my metaphors here. But if space is being created, then time is being created. Oh, okay. Time is being created. Now, the past is done. The past has happened. Oh, what is this? A wonderful poem about that. Uh, Not even heaven itself upon the past has power. Um, anyway, the but new time is being created. So my simple, I almost think of it as an observation that if we have free will, we can't exercise it on the past, or maybe we can. I can talk about that later. But time is being created, and it's during that creation, that new time that's coming about. That's when we can exercise free will. That's when it isn't set yet what is happening right now. Am I going to clap my hands? Thought I was, and I didn't. That was my free will. So we can exercise free will, but you can't exercise free will in the past. You can only do it now. And that's why now is so important to us, because it's when we make decisions, it's when we do things. The past is done, but now will be important. And so this is why of the entire length of time, this is why now has such really great importance to us. Now, my own view on this is that I don't like to get into religion, but the existence of the soul to me is something that's obvious, and uh, maybe it's the soul that's making free will. I don't know. There's certainly things in physics, things in this universe I can demonstrate cannot be done in physics. There are realities other than physics, and many physicists at this point now dismiss me because they have their own religion. Their religion is, if it cannot be explained by physics, then it's not real. And it's interesting to think of that. I've had people say that to me. And I say, oh, where did you learn that? That's self-evident, or is it something that your high school teacher told you and you've always accepted it since then? Did you go to a hotel room and you found by the bed, there's a book called The Book of Physics, and you open up and it says, if it's not in this book, it's not real. This is your religion, that if it's not physics, it's not real. It's not, you can't conclude that. It's not based on observation, certainly. It's a religion taken on by many, many physicists and many non-physicists. So let's recognize that as religion. And like all religions, it sometimes oversteps its bounds. Many religions got into trouble because they were making physics-like predictions that turned out not to be true. And let's recognize the fact that free will is all part of this. And the only time you can exercise free will of all the time of the last 15 billion years, there's only one moment in that time scale when we all can exercise free will, and that's what we call now. So there's my book. You don't have to read it now. Now.
No. There are still lots to read. And actually, you mentioned about determinism and physicalism and the concept of the soul, that how you described it in your book, which is very, very interesting. And I think that some of these topics will also try to discuss a little bit here. But there's also a thing that I would like to ask you about the direction of time. And according to your book, it's a question that you often asked different physicists. And let me now ask you, what makes time move forward and not backwards, or this more bizarre formulation, why do we past and don't remember the future?
Well, because the future doesn't exist yet. That's why we don't remember it. The past, in some sense, does exist. The word existence is kind of funny. I can ask you if the square root of 2 exists, and what does that actually mean? But the past did happen, and that's why we can remember it. The future hasn't happened, and what will be in the future depends on our free will, and we don't know how that's going to be exercised. So there's no real problem with that unless you take the phony physicist point of view that time is all laid out, the whole universe exists, and we have this illusion that we're moving through it. But that's so ridiculous. It amazes me that more people don't simply say that's ridiculous. It probably takes having a PhD and a very high income from selling books to give someone the authority to say something that's utterly nonsense and and pay it attention. It reminds me of the Groucho Marx line in one of his movies when you probably don't know Groucho Marx, but he was a famous comedian mostly before I was born, in which he says to somebody, "Are you going to believe me or the evidence of your own eyes?" Right. Uh, Believe me, this is what these physicists are saying. They're the Groucho Marx. I'm going to start using that term. They're the Groucho Marx physicists. They say, believe me, not the evidence of your own existence. An illusion. The movement of time is an illusion. You can say life is an illusion. Descartes, one of his great insights, was in this little statement he made that I can doubt everything except my ability to doubt.
Thank you. There's also something about the future, which is, oh, I'm sorry, I have to admit another person. Well, the future is something that we're in one way curious about, but we are also sometimes anxious to think about it. And my next question, I don't want it seem provocative because as I've already heard from your book, but I mean, speaking about time, it's all provocative and speculative. So even if I try, it will be hard not to. But and especially including the fact that from your book, I realized that you're not a huge fan of the idea of determinism and that you're actually not really fascinated about the
Well, let me just
doubt.
interject. Let me just interject. Determinism is dead. Now, there's a famous statement a few years ago that God is dead. That was nonsense. But there was a kind of God, what I call the Santa Claus God. You pray to him so your football team will win. That God is dead, okay? But not God, not the real God. But determinism is dead, absolutely dead. It was killed in the early 1900s by quantum mechanics. So there is, I mean, and no educated physicist would defend determinism today. Some philosophers might, which is why it's really hard to be a philosopher if you don't have an advanced study in physics. I'm sorry, I interrupted you.
No. That's okay. I mean, I was prepared for this from your book, but it's still something that interests me from the point of view of theoretical. Um, it's not the paradox, but probably the this idea about. Sometimes we speak here at our Kunsht cameras about different demons, and there's a thought experiment which is called Laplace's demon. Do you find it as ridiculous as the idea we already talked about, the illusion of time? I mean, from your point of view, from everything that you know about time and everything that you know about the possibility of the free will. Does this thought experiment make sense and can really exist? I mean, hypothetically, theoretically, of course, such a being as it was in the original words of Laplace's demon, or as we might think about it now, a machine or a computer that can comprehend the past or the future of the whole universe, knowing its current parameters?
Well, the future, no. Again, the future is not determined yet, and the future will be determined in part by you and anybody who's listening to this program. You may think your influence is small, and it may be, or it could be huge, and it may be, or most likely it'll just be part of a lot of other people all determining the future. But no, the future is not there yet. You cannot see the future. I mean, some of this is more evident than the rest. I like to look back on my past and talk about the things that I uh, never predicted, never saw happening, and yet did occur. The latest AI revolution is one of them. Here I am. I know physics. I know math. I didn't see this AI revolution happening. I didn't see it coming. I could not have predicted it, or at least anyway. But I'd like you to be a little bit clearer in your question. Could you give me the question again?
Do you find the idea of this experiment thought, which is called Laplace's demon, ridiculous, or does it make
What
sense?
is? Tell me what Laplace. Not only for
Well,
me,
actually,
but for all of our listeners, explain what Laplace's demon is.
I think that you actually answered that part that I was asking because it was interesting for me. If we theoretically can understand, can have the data about the state of the whole universe in like the future or the past, you said that it's not
Okay.
possible in the future knowing its current parameters. So I think that you actually answered this question.
Okay. I guess Laplace's demon is determinism. It's the thought that there might be something, machine or person or demon, who can see the future. But how dull that would be. If that demon could foresee the future, then there's nothing that the demon can do about it. Okay, well, great. Um, it, it, it's uh, it's like the story of the judge who was told by the prisoner who had just been convicted of multiple murders. And he said, Judge, it wasn't my fault. This is all brought about by all these influences on me. And there's nothing I could do other than commit these murders. So uh, it's not my fault. And the judge says back to him, I understand completely. And it's not my fault that I'm sentencing you to die, uh, to be put to death and executed. It's all the influences on me in the past. So don't blame me either.
Thank you very much for this answer. We sometimes speak here about either like demons, as we already did, like Laplace's or Maxwell's, sometimes about paradoxes. And these ideas, like paradoxes as well, they kind of, I don't know, stir up our imagination in particular. So yeah, paradoxes, they do the same. And I remember I came across at least three of them. Maybe there were more. I don't remember that. I remember you described the twin paradox, the Barn-Paul paradox, and the
Hmm.
tachyon-mother paradox, which is
Hmm.
extremely interesting. I've never heard about it before reading
I
your
made it
book.
up. I made it up.
You made it up. Oh, that's
I
that's
made
an
it up.
explanation. That's an explanation why I have
Yeah, the tachyon
it.
murder.
So, well, my question was about, and still is about, which is your favorite one of these paradoxes? I mean, if favorite is the correct word here, I mean, which one impressed you the most when?
So I continue answering in hopes that she will get back online.
Yeah, sure. I think you understood the question, so you can answer now.
Yeah, a paradox in in science, in technology, in math, is always something that's resolvable. And just a funny thing about the way the term is used, it's misunderstood by much of the public. A paradox is an apparent disagreement between two different ways of approaching the same question. Just a second. Two different ways of approaching the same question. And all of the paradoxes of special relativity are things that really confuse the public, but for which Einstein had addressed already in his original theory. And he knew the answers to these, and there were good answers. And the twin paradox. Well, if John and Mary go different paths, and they were born at the same time, but they come back, and now one's old and the other isn't, that seems paradoxical. But no, it's completely explained in general relativity. That's why I say Einstein gave us the gift of time, because he showed us that there are these results that are completely unexpected, that can be readily explained. And to the non-expert, they're paradoxical. How can two people be the different ages? And wait a minute, what about from John's point of view or Mary's point of view? Shouldn't the other one always be younger? Or what goes on? It's all completely explainable. And I try to do that in my book, The Pole in the Barn, and the tachyon murder paradox, which says if I shoot you with a gun and the gun shoots out a tachyon and it's a tachyon that kills me, then there is a reference frame in which the death occurred before the tachyon was shot. And does that violate something in physics? I mean, it violates causality. And my answer is right. Causality is not an established principle of physics. We treat it like it is, but how do you test it? How do you prove it? If we have tachyons, causality is out the window. If we throw causality away, we're throwing away free will. So the reason, I mean, I know I have friends who are searching for tachyons, and the only thing I can do is not join them. I consider it a waste of time, because if tachyons exist, then in the tachyon murder, there's a reference frame, a valid frame in which the death took place before the trigger was pulled, which means that the person at the gun had no choice but to pull the trigger. That doesn't violate physics, but it violates free will. And since I have a spiritual sense that free will really does exist, therefore my friend is not going to find a tachyon, and he may, and that'll completely fool me because it's a test you can actually do, but I'm not going to, I was going to say, waste my time doing something where I'm convinced that if I found it, it would indicate that I had no choice but to do the experiment. I lose all my free will if tachyons exist. Now, the physicists who ignore free will, well, search for tachyons. But they should recognize at least that if they find free will, if they find tachyons, they are ruling out free will. It's an interesting fact that in that sense, free will is testable in physics. It predicts that tachyons will not exist. Nothing in special relativity, nothing in relativity, general relativity, nothing in physics precludes the existence of tachyons. The only thing that precludes it is that it's in conflict with free will.
Thank you for inventing this paradox. I actually didn't know that you was the author of it, and I'm sorry that I lost the connection for some time. So I went to fix the internet. Sometimes we have this electricity and internet problems here, but since you, I mean, I'll listen to this part of your answer already in the recording, but also I would like to ask you about what happens with time in and around the black hole. Can you ask us a little bit about how time behaves if we can say so, on the event horizon, and what happened to the observer there and to the observer outside, who sees everything, and what happens with time already inside a black hole.
Okay, well, you asked about 6 really good questions. Let me begin by saying that we've got to stop using this sentence, according to an observer. Because in relativity theory and in physics, all observers always agree, 100% agreement. There's never disagreement. There's a prominent, well-known, famous physicist who does a lot of TV shows and such, and he read my book and he said, "Never again will I claim that according to this observer, this happens, and according to this observer, that happens." I think when you say that, you lose people. They say, "Oh my God, if the results depend on the observer, then look, if I shoot a gun and I'm shooting it at someone on a train that's moving fast, and according to me, the bullet is moving 1,000 feet a second. And according to someone on the train, it's moving 500 feet a second. What I just said violates all rules of science. What I said was wrong. It's not according to a person on the train, it's moving 500 feet per second. The correct statement is, according to someone on the train, the bullet is moving 1,000 feet per second on a reference frame with the Earth, and 500 feet per second on a reference frame moving with him. And the same statement is true for the person. So all people agree, all this black hole stuff, is don't forget the observer. We know what happens in black holes. They've been around for a long time. They don't depend on relativity theory to exist. A lot of people think they do. They would exist even with Newtonian physics. They don't depend on Hawking and his black hole thermodynamics, which is all very interesting stuff. But black holes are simply things where the gravity is so intense. They depend on relativity theory in the following sense. If you want to escape to space, you take energy to do that. Suppose the energy to do that was more than your MC squared energy that you had. So then you could never get out, because it takes more energy than the maximum energy you have. And that's a black hole. Black hole is simply an accumulation of mass where the gravitational pull is greater, more energetic than the total amount of energy you could possibly expend in getting out. So it's not a very deep concept. It's often presented as very mysterious. Where it gets strange is when you start applying Einsteinian relativity to it. And this has been depicted correctly in several movies, in which, as you get close to a black hole, time slows down enormously. At the surface, it essentially comes to a stop. But you experience that in your own home. When you go downstairs, time speeds up. And you go upstairs, it slows down. Now, this is not anything new. And not only that, but we can measure that in your home. We have clocks that are good enough now that we can do the whole twin paradox thing. Have a clock down here, click, 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 but it has to be a really good physics clock. And then you take one upstairs, leave it up there for a few minutes, and bring it back down. Now they will disagree. Well, that's because what they show is how much time has expired in their own environment. And when you go up higher, I guess time goes faster when you go up higher. So these things are all well known, and the black hole is simply an extreme. Now, it gets to the following wonderful, wonderful extreme. Suppose I jump into a black hole, and if it's a big black hole, I will survive. Then how long does it take me to reach the surface of the black hole? It depends not on the observer, but on what reference frame you use. That's important to know, because all observers agree that in the reference frame of the Earth, with the black hole over there, the amount of time it takes to reach the surface of the black hole is infinite. So you can't go in a black hole, at least not in that reference frame, not in the Earth's reference frame. But if you consider a co-moving reference frame, one that's tied to you, then you get into the black hole pretty quickly. And now you're inside. And you say, what's going on outside? Well, they've gone past infinity. What? The time frame outside the black hole is past infinity, but here I am? Let me go out and see. Well, catch, you can't leave the black hole. Can't go back out. It all fits together in a marvelous way. What is it like being inside a black hole? I think that's best explained by the concept, which now appears to be incorrect, that the universe itself expands and may contract. And now we know, no, it doesn't seem to be the case. But let's go back to the old theory of a universe, of a universe that had enough mass in it that it would contract. If that's the case, then we are all inside a black hole right now. We call the black hole a universe. Why do we call it a universe? Well, obviously you can't leave the universe. You can't get outside of it. Like the guy in the black hole, that's all there is. And what is it like? Well, here we are.
Wow, this is really mind-blowing, but everything about time is time-blowing. And there's one thing that would really, I actually promised to our community
We put on
members that
pause for just a second. Pause just for a second. Hello, Alex. I'm being interviewed online. Is this urgent? Thank you. Okay, sorry. I'm back.
That's okay. Okay, at the beginning of our interview, you already said that time travel, traveling back in time, no, sorry, impossible. But what would you say about traveling to the future? Like, because it is believed, well, that's what some physicists say, that you just have to accelerate well enough and it will be possible to travel to the future. What would you say about it? Is it, again, theoretically possible to travel in future? And
Whoa. Wait a minute. We are all traveling to the future right now. Now, what's the question? Can you travel to the future quicker? If we weren't traveling
Yes.
to the future, there'd be no flow of time. Well, you could travel to the future quicker by going to sleep. And you wake up and, oh my God, it's 8 hours later. So yeah, we can travel to the future. Can we put us in suspended animation? Could we slow my own personal time down by making me go fast? And then I will be the same age I am now, but the universe will be 1,000 years older. Yeah, we could do that too. It's sort of like taking a nap. You travel to the future. Travel to the future is what we do. So the question is we can travel to the future. The trouble is we can't come back.
The way we do it right now, there's no magic. So that's why.
What do you mean no magic? This is one of the most magical things in the universe. The flow of time, free will. Compared to here's magic. Want to see magic? Watch this. Okay, ready? 1, 2, 3. Boom. There. Is that magic? No, that's not magic. And the real magic of the world is the world. And just because it's common and you take it for granted and you're used to it doesn't mean it's not magic. It's magical.
Okay, thank you for that. And another one question that it's like the last from me. My last question is always
Again,
a
hold
weird
for a
question.
moment. Rosemary, can you get that? Okay, go ahead.
So my
I have
last
a guest
question.
who's coming now. Go ahead.
Sorry? Yeah. So as I said, my last questions are sometimes the strangest. And this one came up to me when I wrote about how you described flies, that they are faster than us, and our behavior for them is like, I'm not quoting you, but it's like it's slow motion for them. We are slower than flies who lives shorter lives and can do fast things. So it seems like other species generally perceive time differently than humans. Like they don't keep calendars, but they have their own rhythms, their own
Mhm.
cycles. And the last time when we had this Kunsht camera, I mean, 2 weeks ago when we had to talk to you for the first time, I remembered this because we started just chatting about time and its weirdness and paradoxes together within a group. And I remembered these creatures who are periodical cicadas with their 13 and 70 years life cycles. And these are only the creatures who live here on this planet with us. And the crazy question is, have you ever wondered what the perception of time might be in some other intelligent being somewhere outside of Earth? And this question
Just
is
read Tolkien. And Tolkien talks about this in beautiful precision. The Ents, Ents, those are trees. And they think if you do something in less than a year, you're hurrying. So what you're talking about is physiological time. And physiological time is quite different. Our physiological time is set by our size, by the speed of nerves, by how rapidly we can, if you put your finger and you accidentally prick it, you pull away before you even know it's been pricked, because the nerves don't bother going all the way up to your brain. They just say, get back out of there. So physiological time is something different. Many people get hung up on that. And I just ask, the glory of physics is that we can discuss reality without discussing the human perception, colors. So greatest illusion of all time is you look at a TV screen and it's white, and if you go up to it with a magnifying glass, you discover there's not one pixel of white in that whole screen. It's all red, green, and blue. So we have all of our illusions and so on, but physics stands apart from those. So that's
Thank you
physiological
very
time. That's an interesting subject, but it's not the subject of my book.
Yeah, I mean, I'm not asking you as I would ask a biologist. I was just wondering, how did you? I mean, if maybe you watched or you read the science fiction novella by Ted Chiang, which is called "Story of Your Life," or the movie based on it, which is called "The Arrival," about the creatures whose mindset gave them an opportunity to see not only the past but also the future, because they had different I mean they understood time
All it
differently.
takes to see the past is to have a really long life. So turtles see more of the past than we do, but again, that's physiological time, and that's one thing that I think is not of great interest to me. It's fun to talk about, but it's not really the subject of my book or of any mystery.
Thank you very much for that. Thank you for all of your questions. And I think maybe Carrillo or Marta, who joined a little bit later, maybe they would like, or somebody else to ask something. And if you have like a couple of minutes, additional minutes, maybe we
Well,
can
I do have
ask
a
them.
guest who's just shown up. So if you want to ask a few questions very quickly, we can do that. But I need to, or we can resume this at some other time. but right now I don't have a lot of time.
We're just really grateful for for this interview. It was very interesting. So we'll not take more of your time. Thanks so much for your answers.
Taking my time, an interesting concept.
In the future,
Thank you very
your
Okay, good. Thank you very much.
Thanks a lot.
Thanks a
Okay.
lot.
Bye.
Thank you. Bye.
Thank you. Have a good day.
Thank you. And may your country fare well.
Thanks for your support.